Hello friends, this video on chemical bonding part 32 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure you have watched part 1 to part 31.
Let's take some question. Let's explain the formation of chemical bond. Very basic question. Why do we have chemical bond? Chemical bond is what? Attractive force that binds atoms or ions together. Correct? And there are various theories for the chemical bond. We have VSEPR, we have valence bond theory, molecular orbital theory, and we have Lewis theory. There are so many theories for chemical bond, right? But all these theory talks about the fact that a chemical bond is formed to attain stability, right? To reduce the energy. Stability is the goal of all the atoms, and that's why they combine chemically. It was observed that the noble gas have filled outermost electrons and hence they are stable, right? So it was postulated that elements having incomplete outermost cells are unstable. By observation, they have seen that they are some of the stable elements, they have complete outermost cell, and they are unstable elements for which the outermost cell is not complete, right? And that's why it says that atom combine to reach the nearest noble gas configuration, either by transferring electron or sharing electron. Correct? So this can occur by transferring or sharing electron based on we are talking about covalent bond or ionic bond. So when it shares electron, it's called covalent bond, and when it transfers electron, it's called ionic bond. That's the whole story about bond. So there are various theories, but the main theory is about the stability, to attain stability. To attain stability, either they sometimes transfer electron or sometimes share electron. So we have different scenarios I explained. For example, sodium chloride, sodium ready to give electron, one extra electron it has. If it gives electron, it will become stable. Fluorine is ready to take one electron. Now when it takes electron, it becomes stable. So in that case, transfer of electron will take place. But for example, we have hydrogen and hydrogen. Both are not willing to give electrons, so they will share the electron. So this is the ionic bond and this is covalent bond. To rise the Lewis dot structure, manganese has 2 valence electron. This is my Lewis structure. Sodium has 1 valence electron. Bromine has 3 valence electron. Oxygen has 6 valence electron. Nitrogen has 5. And bromine has 7. Right? So this guy 2, sodium 1, boron 3, oxygen 6, nitrogen 5, and bromine 7. This is my Lewis dot structure. A symbol actually. We write the Lewis dot symbol for this. Sulfur, it has 6 valence electrons, so sulfur will be 1, 2, 3, 4, 5, 6. Correct? S minus 2, 2 more extra electrons it has got. So it has 8 electrons. Valence. 1, 2, 3, 4, 5, 6, 7, 8, and minus 2 charge. Correct? Aluminium has 3 valence electron. Aluminium plus 3, no valence electron. Why? Because 3 is gone here. Right? Plus 3 means 3 electrons are gone. Hydrogen has 1 valence electron. Hydrogen minus 1, that means 1 extra electron it has got, and it has got a negative charge. Correct? Now we will draw the structure. Please understand the difference between symbol and structure. So when we talk about sodium, potassium, these are all symbols. But when we talk about structure, we talk about structure of molecule. Right? We talk about symbol for atoms and we talk about structure for molecules. So if we draw a structure for H2S, let's do this first. Sulfur, 1, 2, 3, 4, 5, 6 valence electron, and hydrogen I have. Right? So let's join these H2S. This is the Lewis structure. Correct? SiCl4. So let's draw SiCl4 like this. Silicon has 4 valence electron. Chlorine has 7. 7 into 4, 28 plus 4, 32. So we start with 32. We have 4 bond, 8 electrons gone. So we have 24. Each of the chlorine will need 6 electron, correct, to attain the valence state, because each has 2 now. So each will take 6. 24 is also gone, and they are stable. Let's take BEF2. Let's draw it BEF2, BEF and F, sorry. Right? Beryllium has 2 valence electron, fluorine has 7. 7 into 14, 16. So out of 16, my 4 is gone in the bond, 2 bond, we are left with 12. Beryllium is happy. We have 12 electron, will give 6 each to this fluorine. They will also be happy because fluorine has 2 electrons now. Correct? Let's take CO3 minus 2. So we have carbon, we have oxygen, oxygen and oxygen. So we have carbon, we have 4. Oxygen we have 6 into 3, 18, plus minus 2 charge, we have 2, we have 24. We know the structure of this, we have done this in the previous, in a few of the videos before, so I will not spend time on this. The structure of CO3 minus 2 is something like this. If you have issues, you can just watch my previous videos where we explained the structure of CO3 minus 2. It's a resonance structure actually. Similarly, HCOH will be something like this. I'll not spend time on this, how to draw the structure, because we have done this example in the previous videos. What is octet rule? What are the significance and limitation? So octet rule says that atoms combine either by transfer or by share of electron, the valence electron, to attain the nearest noble gas configuration in the valence cell. So valence cell should have noble gas configuration. To achieve that, they combine either by transfer of electron or sharing of electron. The limitation of theory, the first thing is it failed to predict the shape or stability of the molecule. It is based on the noble gases inertness, but there are some noble gases which form compound like XeF2. It cannot be applied for third period elements because they have d orbitals also. They can have more than 8 valence electrons, and this is not satisfied for all the atoms having odd number of electrons. For example, NO, NO2, they don't satisfy the octet. What are the favorable conditions for forming of ionic bond? So very simple: low ionization enthalpy of metal atoms, high gain enthalpy of non-metal atom, and a high lattice energy. Because as I told that, for example, you have Na plus and Cl minus becomes NaCl. So there are 3 energy involved. First is the ionization energy, right? You get Na plus. Then electron gain enthalpy energy. In this you get Cl minus. And in the lattice energy, where you form the lattice structure. So if this is low, because this has to be given always, right? This is endothermic. If this has to be low, this you are talking about high exothermic plus high value of this is low value of this, and high, because this is exothermic always. The lattice energy is always exothermic, so we are looking for high value of this lattice energy, high value of this guy. This is this, this is this, this is this. So since the ionization energy is always endothermic, so we are looking for low value of this. Electron gain enthalpy can be exothermic or endothermic both, so we are looking for high exothermic value of this. The lattice energy is always exothermic, so we are looking for high value of this. So if we have these, it is a favorable condition for forming ionic bond. We discuss the shape of BeCl2, BCl3, SiCl4, all these using Vesper theory. So let's try this. BeCl2, BeCl, Cl. There is no lone pair, so it is 2 bond pair plus 0 lone pair. What does it mean? It means linear. Correct? That's what my best path theory says. Then I have BCl3, I have BCl, Cl, Cl. There is no lone pair also here because group. The boron had 3 electrons in the valence shell and everything is filled. So there is no lone pair here. So it has 3 bond pair plus 0 lone pair. So it is trigonal planar. Correct? Let's talk about SiCl4. Si also, if you see, it has 4 valence electron and all are filled now, right? All are used in this bonding. There is 4 bond pair but 0 lone pair, right? So this is a tetrahedral shape. If you're having issues in understanding this, watch the previous watch the videos on this where we've explained that if there is a 4 bond pair and 0 lone pair, it has to be tetrahedral, right? We talk about AsF5. So AsF5 also, if you see, I'm just drawing like this, just like that. It has 0 lone pair, 5 bond pair and 0 lone pair. So in that case, it was trigonal bipyramid. We talk about S2S. So you have sulfur, you have hydrogen, hydrogen. So you have 1 lone pair. So you have 1 lone pair plus 2 bond pair. That is a bend shape. Then we have PH3. So we have PH, H, H, and then 1 lone pair here, correct? Because phosphorus has 5 valence electron, 3 is used in bonding, 1 pair is free. So it is 3 bond pair plus 1 lone pair. So 1 lone pair and 3 bond pair gives trigonal bipyramid. This is something we should remember actually. So 3 bond pair plus 1 lone pair gives what? All this thing we have to remember. The question says, although the geometry of ammonia and water are distorted, tetrahedral, bond angle in water is less than ammonia. Why? So if you see this ammonia, NH, H, H, and water, in water I have 2 lone pair. In ammonia I have 1 lone pair, right? Because ammonia has 5 valence electron, 3 is used in bonding and 2 are here. Oxygen has 6 valence electron, 2 is used in bonding and 4 are free. So if you see, this guy has 1 lone pair plus 3 bond pair. This guy has 2 lone pair plus 2 bond pair. So this guy repulsion is more. That's why the bond angle of water is less. This angle is less. Correct? Repulsion is more, the angle is less. How do you express bond strength in terms of bond order? As I told that bond strength is directly proportional to bond order. So if you have triple bond, more strength, double bond, less strength, single bond, less strength. So it is directly proportional to bond order. What is bond length? So bond length is nothing but equilibrium distance between the nuclei of 2 bonded atoms in a molecule. So there are 2 atoms in a molecule. The equilibrium distance between these are, and this is nothing but sum of the covalent radii actually. And they are expressed in terms of picometer or angstrom, and they are measured by X-ray diffraction, spectroscopic, and there are so many electron diffraction techniques. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.